Hey, so this is our first homework assignment on our unit on meteorology, and meteorology is basically the study of weather and climate. We'll talk about the difference between those things, but really the very basic difference is that weather is short term and in a local area, so what's going on right here, right now, or over the next couple of days, and climate is more of an overall average of what's going on the Earth over periods of 10 years or 100 years or even thousands of years. So during this unit, we'll talk about weather forecasting. We'll talk about extreme weather conditions like hurricanes and lightning and things like that, tornadoes. We'll talk about types of clouds, and we'll talk about weather measuring instruments and all that kind of stuff, as well as things like climate change and all that kind of stuff. So let's go ahead and get into it. As usual, remember that red slides mean you have to take notes. You should have your Inner Planets handout to go along with this, and don't forget to look for the owl. At the end, make sure you tell me where the owl is and summarize what you've learned in a few sentences. So first of all, weather is the state of the atmosphere at a given time and place with respect to variables such as temperature, moisture, wind, and air pressure. So in order to really get an understanding of how weather works, I think we need to start off by talking about the atmosphere itself, because after all, that's where the weather happens. So I'd like to start off by pointing out just how thin our atmosphere is. So this picture of the Earth taken from space, we can see the atmosphere, and it's only that thin little layer there. If the Earth were the size of an apple, the atmosphere would be about as thick as the skin of the apple. And the reason why I'd like to point that out is just to show you the idea that we really don't have that much atmosphere to deal with. So we can have an impact on this atmosphere. So the atmosphere is the layer of gases surrounding Earth, composed mainly of nitrogen and oxygen. The atmosphere, though, has gone through a lot of changes over the history of the Earth. The Earth has been around for about 4.5 billion years, and so we need to take a look at the changing atmosphere of Earth. A lot has happened to the Earth over that period of time, and so a lot has happened to the atmosphere over that period of time. And basically, we can kind of break this up into three distinct time periods for our atmosphere, where the atmosphere was very different during those time periods due to specific events that happened on Earth. So in this little chart that you're going to make here, think of the idea that we're going to talk about the first atmosphere, the second atmosphere, and then our current atmosphere now. And we're going to talk about what it was made out of and what happened to it to make it change into the next atmosphere. So our first atmosphere was mainly composed of hydrogen and helium from the solar nebula. And if you remember how the Earth formed in the first place, and in fact how our solar system formed in the first place, this shouldn't be too surprising. This is a nebula right here, and this is the place where stars and solar systems and things like that are born. And if you recall, this is what you're looking at. Most of this is hydrogen and helium. In fact, that describes most of the stuff in the universe is hydrogen and helium, so it's not too surprising that these nebulas are made out of it, and it's not too surprising that our first atmosphere would be made out of it. So let's think about how this formed. Well, if we take a small piece and kind of zoom in here to this idea, we can see this closer up, and then we can see it zoomed in even more, and right here is an actual picture. This is pretty amazing. This is an actual picture of a solar system forming. In the center there is the star, and this is sort of what they call the protoplanetary disk, the area where all of the planets and asteroids and comets and things like that are starting to form and starting to come together. So if we zoom in on that even more, we can imagine something like this. This is not a picture anymore. This is an artist's drawing of this, but this is basically what it would look like. All of this gas and dust starting to kind of swirl around, and you can think of like a pizza maker throwing a pizza dough up in the air and how it spins around and starts to flatten out. That's exactly what happens to the gas and dust that forms our solar system. So if we take a look at that and zoom in a little bit more onto one of these planets here, you can see this idea that it's surrounded by all this gas and dust. And remember, gravity is sort of the key force that's happening here, and gravity is pulling in all of this gas and dust and clumping it together into this newly forming planet that might one day become Earth. So once that happened, then we start to get the influence of the sun on our solar system, and the sun erupts with its nuclear explosions and sends solar winds hurling out into space, and it would look something kind of like this, where you have all these sort of charged particles that are being shot out by the sun and flying out through space. And so the Earth, a very important part of this, and we'll talk about this in another time, but at this time the Earth did not have its magnetic field yet because it wasn't quite done forming. So it didn't really have any protection against this. The Earth's magnetic field protects us from all these rays. And so that initial atmosphere was basically pretty quickly blown away by these solar winds. And that brings us to our second atmosphere. And our second atmosphere was composed mainly of H2O, which you know is water, CO2, which you know is carbon dioxide, and SO2, which is sulfur dioxide. And this came mainly from gases erupting from the Earth. This is a picture of what the Earth probably looked like. It probably looked something like this in its earliest days of formation. We can see the newly formed moon here, which came from, we think, probably a collision with another planet, which sort of broke the chunks off that formed together into the moon, and you can see that forming there. You can also see right over here some volcanic gas coming out and erupting out of a volcano. So that's where our second atmosphere came from. It was basically all of the gases coming out from inside of the Earth and erupting to the surface and being held to the Earth by its gravity. Now, over time, the Earth starts to cool, and the early Earth would go from looking like this to looking more like this, a little bit more like what we're used to, right? But still kind of not quite completely solid on the crust yet. And then it started looking like this, and if you look at these land areas, you can start to see some green colors in there, and that is a really important part because this is when we first start getting the first life on Earth. And so this is a very important big moment on Earth, and the early life on Earth would have first been bacteria, but fairly quickly started becoming ocean plant life. And so life kind of started in the ocean, and plants started growing in the ocean. And as you guys know, plants do a very certain specific thing here. So the Earth started kind of looking more like this, and the plants start breathing in all of that carbon dioxide that's in the atmosphere, which kind of makes sense if you think about it. Obviously, the first life on Earth would have to be well adapted to the environment of the Earth at that time. And since there was a lot of carbon dioxide in the atmosphere, it makes sense that life would start to take that in and use it as a resource. And basically, the byproduct of that, or the waste product of that, was the oxygen part of the carbon dioxide. Notice that it is keeping the C and spitting out the O2 part, right? That's basically how plants work. They take in carbon dioxide, they spit out the oxygen part of it and keep the carbon part. You can think of plants as being kind of mostly made of that carbon. So an interesting way of thinking about this is that we think of plants growing out of the ground usually, but really it's kind of more accurate to say that they grow out of the air. Obviously they take nutrients from the ground as well, the water and the stuff in the soil and things like that, but really most of the stuff that a plant is made out of actually comes from the air, not the ground. So that second atmosphere was transformed by photosynthesis and leads us to our current atmosphere. Our current atmosphere is mainly N2, or nitrogen, O2, oxygen. Notice that those two atoms kind of tend to pair together. Nitrogen tends to to be in pairs of nitrogen floating around in the atmosphere, same with oxygen. And so this was created by photosynthesis from plants and constant N2 production, constant nitrogen production. Now this is kind of complicated. We don't really have to get into this in too much detail, but nitrogen production, this is caused, this is kind of a good example here. You can see some dinosaurs eating some plants and things like that. You can see some decomposition happening here and that kind of stuff. And that really kind of describes what's going on here. It's basically what we call this. This is what we call nitrogen fixing, which is a really complex process that has to do with the interaction of animals and plants and the animals' waste products. You can see that you have a lot of different stuff going on here, but a lot of it has to do with basically animals eating plants and digesting it, and then the waste products that are produced from that. That's how we get a lot of the nitrogen in our air. And I think it's to kind of keep in mind here the idea that our atmosphere, we kind of think of when the air around us as being oxygen, but it's really mostly nitrogen. So we continue to have small changes due to climate changes, natural climate changes, and I put a question mark after the human activity because I guess we probably have to talk about that in class. A little bit of a controversial subject these days, but we'll talk about whether humans are causing the climate to change and changing significant changes, creating significant changes in our atmosphere and things like that. All right, so the atmosphere is basically made out of 78% nitrogen. Like I said, it is mostly nitrogen. And when you think of the air around you, you might think, well, I'm not really familiar with nitrogen and what that is. I think I know what oxygen is, but I'm not really sure what nitrogen is. Well, you are actually very familiar with nitrogen. Nitrogen is around you all the time. It's mostly what the air is. 21% is oxygen, and if you've done your math, you may have noticed that there is about 1% left over here, and that's all this stuff. I certainly don't expect you to memorize all these different gases, but some things to take a look at here are the fact that carbon dioxide makes up about 0.2% of our atmosphere, kind of a small amount, but we'll talk about whether or not that's enough to make significant changes and that kind of stuff. All right, what I would like you to do now is make a little pie chart that shows the composition of the atmosphere. Look for this part in your notes here and make a pie chart that looks kind of like this pie chart in your notes. All right, now we need to talk about layers of the atmosphere. This is kind of an interesting thing. We'll talk about this more later, but basically when the Earth formed, it formed layers. And usually when we think of it, we think of the Earth forming layers and the crust being kind of the top layer. That's the layer that we stand on when we're walking around on the Earth. But I like to think of it that the atmosphere is really just another layer of the Earth. That's where all the lightest elements are that floated to the top. Things like oxygen and hydrogen and helium and nitrogen and stuff like that all kind of float to the surface. And the surface is really kind of the top of the atmosphere. We're just sort of in the top layer of the Earth. So, layers of the Earth. Make sure you guys are taking note here of where to write things on your notes. I'll try to help you out with this, but one thing to notice is that for the rest of this homework assignment here, you will be doing your notes from the bottom up. Okay, so as you do this, you have your notes that look like this, and what I would like you to do is you're going to kind of write some of the things here, definitions and whatever, in this area, and I would also like you to draw a few pictures of the different types of things that we find in that part of the atmosphere as we go through this. Okay, so it's going to kind of look like this, and we're starting off with this lowest part of the atmosphere right here, which is where we live. Here's some little mountains and things like that. That's where we live, and that is what we call the troposphere. So the troposphere, this is where weather occurs, and we're going to have clouds in this area, mountains in this area, all of that kind of stuff. All of the weather that happens here in the troposphere. Next, we're going to move up to the stratosphere. The stratosphere is where jets fly. This is also where the ozone layer is, and we'll talk about the ozone layer. Next is the mesosphere. Mesosphere is where meteors burn up. So whenever you see a meteor shower and you see those meteors flying through the sky, that is where they're burning up. The next layer will be the thermosphere. thermosphere is basically where most satellites orbit in the upper level, which is called the exosphere, and auroras happen in the lower level called the ionosphere. Notice that we break the thermosphere up into a couple different layers here, and they actually do that with pretty much all of the layers, but we're going to try to keep it fairly simple here, but that we will break that one up into two parts. So this is kind of another shot of this idea of the layers of the atmosphere, and you can see that here we have this whole area here is basically the thermosphere, and this part here is where the ionosphere is. Then we get to the exosphere kind of right at the edge here, and right about that area where it goes from being the ionosphere to the exosphere is where we consider it that the atmosphere basically fades out into space. There's not a real firm boundary line between the atmosphere and space. It just gets thinner and thinner and thinner until we get into outer space. So that's right about there is where we consider the atmosphere to be so thin that we call it outer space at that point. All right, now another thing that we need to know about these layers of the atmosphere is the idea of how temperature changes as we go up through the atmosphere. So first of all, I want you to think about this as a starting point, because as long as we get started in the right direction here, it's very easy to remember how this goes. So first of all, why do mountains have snow at the top? Well, because it's cold up there, duh. That's a pretty obvious answer, right? It's cold at the top. That's why there's snow up there and we don't get a lot of trees up there and things like that. So you can kind of get the idea that as you climb up a mountain or as you go up through the troposphere, we get colder and colder. The temperature goes from being warm near the ground and cold near the top. Okay, so as we do this, basically we're going to draw a little graph here in our layers of the atmosphere. So what I would like you to do is kind of make this line here, and it's okay if it goes through some of the stuff that you drew and wrote. That's fine, don't worry. And I want you to start it kind of over to the right over here, and you're going to do a nice straight line that moves diagonally over to the left and stops at the top of the troposphere, just like that. Now, at that point, when we get to the next layer of the atmosphere, the stratosphere, well, now the things are going to start heating up and go the other way. So draw a line that goes from left to right there. And then we're going to go back right to left. And you can kind of start to see this pattern that's happening here and why I said it's pretty easy to remember. Now we're going to go back left to right again, and you can see that it basically just flip-flops each time we get to a new layer of the atmosphere. It's getting colder as we go up through the troposphere, warmer as we go up through the stratosphere, colder as we go up through the mesosphere, and then again hotter as we go up through the final layer, the thermosphere. So question is, why exactly do these temperature changes happen? We need to kind of get some reasons here about why this happens. So as we're doing this, please fill in your notes to the right section over here. We're going to start right down here in this area and start filling in the reasons for why these temperature changes happen. So in the So as you are climbing up Mount Everest, the idea here is there's sort of less air particles up there, and so it starts to get colder. And another idea here is that you are getting further away from the Earth, and the Earth is kind of like a hot frying pan that's on the oven. If you hold your hand right above the frying pan, you can feel the heat coming off of it, but as you move away from it, you don't feel as much of that heat. So as you move away from the Earth, it starts to kind of, that heat source, you're moving away from that heat source, so it starts to get a little colder. You may think, well, aren't you getting closer to the sun? That's not bad, and we'll talk about that in a second, but really a lot of the source of our heat when we're close to the Earth is actually from the Earth soaking up the heat from the sun and then kind of radiating it, again, just like a frying pan that's been heated up on the oven. All right, so as we go up through the stratosphere, it starts getting warmer because the sun's radiation is strong because it's not blocked out by all these air particles. So as you go up through the atmosphere, basically the sunlight doesn't have to go through as much air, and so you start feeling that heat a little bit more. But it starts to get colder again as you go through the mesosphere. And that again has to do with the idea of fewer air molecules as you're going towards space. The fewer air molecules there are, the fewer heat is basically the idea of air molecules or other things kind of bumping in to the molecules on your skin. And so if there's less air molecules to bump into your skin, then it feels less. And our final layer of the atmosphere, the thermosphere, basically starts to get very hot as you're getting closer to the sun and the sun's rays are hitting you. This is kind of an interesting idea. This is a really nice shot from the International Space Station. You can see the arm of the International Space Station right there, and we can see this idea of, like I was saying, of the atmosphere kind of going up here and fading off into space. But we'll talk a little bit about this idea of temperature in space. Is space hot or is space cold? That's an interesting question, because basically space is not really hot or cold on its own. It's only objects that are in space that can be hot or cold. So we'll talk a little bit more about that. It's a little bit weird to talk about the temperature of the upper atmosphere here because there really isn't much stuff there. All right, well, there you have it, the atmosphere, a starting point for us to start talking about meteorology, because after all, that is where meteorology happens. So we basically learned about the ideas that weather is the state of the atmosphere at a specific time and place with respect to the ideas of temperature, moisture, wind, and air pressure. The atmosphere is the layer of gases surrounding Earth and is composed mostly of nitrogen and oxygen. We have three distinct stages of the atmosphere having to do with their composition and the things that cause them to change over time. We have the current composition of our atmosphere, which is mostly nitrogen and oxygen, and we have the layers of the atmosphere, and we need to know the order of the layers of the atmosphere. We need to know some facts about it, the type of thing that happens in it, and we need to know the temperature changes of the atmosphere and the reasons for that temperature change. And we will practice all that stuff and go over it in great detail in class, and I'll see you